Welcome to this presentation on network capacity planning. In this session, we will explore the essential concepts of forecasting and planning network growth to ensure optimal performance and reliability. Network capacity planning is crucial for several reasons. First, it helps prevent performance degradation and outages, ensuring a smooth user experience. Secondly, it optimizes capital expenditure and resource allocation, making the most of your investment. Thirdly, it proactively addresses future demands, keeping you ahead of potential issues. Finally, it supports business growth and digital transformation, enabling your network to scale with your organization. To effectively plan network capacity, it's essential to monitor key metrics. These include bandwidth utilization, which is the percentage of available bandwidth being used; latency and jitter, which measure the delay in data transmission and its variation; packet loss, which is the percentage of packets that fail to reach their destination; traffic patterns, which show daily, weekly, and seasonal variations in network usage; and interface errors, which indicate hardware-level transmission issues. Several forecasting methods can be employed to predict network growth. Trend analysis involves extrapolating historical data to predict future growth patterns. Regression analysis uses a statistical approach to establish relationships between variables. Time series analysis focuses on analyzing cyclical patterns and seasonal variations. And machine learning models use artificial intelligence-based prediction, utilizing multiple variables and patterns to forecast network demands. Analyzing network growth patterns is vital for effective capacity planning. Key insights include identifying the overall growth trend, noting any seasonal patterns, setting up threshold alerts to warn of impending capacity limits, and detecting anomalies that may require further investigation. For example, in the illustration, there is a steady bandwidth increase with a 5 to 7% monthly growth rate, and the utilization is projected to reach 80% capacity in 3 months. There are several capacity planning strategies to consider. The first is just-in-time expansion, where you add capacity only when utilization reaches predefined thresholds. Second is predictive planning, in which you expand capacity based on forecasted demand before thresholds are reached. Third is traffic engineering that optimizes existing capacity through better routing and load balancing. And the fourth is a hybrid approach, which combines on-premise expansion with cloud-based elastic resources. A well-structured implementation plan is crucial for successful network capacity upgrades. The steps are as follows. 1. Conduct a baseline assessment to document the current network topology and utilization metrics. 2. Define the capacity requirements by calculating future needs based on growth forecasts. 3. Create an expansion design with detailed network upgrade specifications. 4. Implement phased upgrades to minimize service disruptions. And 5. Perform validation and monitoring to verify performance and establish ongoing monitoring. Let's consider a case study involving a global financial services company. The challenge was network congestion during peak trading hours, which caused transaction delays. Analysis revealed a 40% growth in data volume over 6 months with predictable patterns. The solution implemented a phased capacity expansion, along with traffic engineering and quality of service optimization. The results showed a 60% reduction in latency, a 200% increase in bandwidth, and network uptime improved to 99.99%. Transaction throughput increased by 45%. To conclude, let's review some best practices for network capacity planning. Implement continuous monitoring systems to track network performance metrics in real time. Establish regular review cycles to adjust forecasts based on actual usage. Utilize trend-based planning by using at least 12 months of historical data to identify seasonal patterns and long-term trends. Coordinate capacity planning with business initiatives and growth projections. In summary, effective network capacity planning is a continuous process that balances current performance with future needs. By implementing structured forecasting methods, proactive expansion strategies, and regular monitoring, organizations can ensure optimal network performance while controlling costs and supporting business growth. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.